Okay, let's jump right into today's lesson, which is 241, functions in the real world. So you can see your learning target here. I can distinguish between real world situations that can be modeled with linear functions and with exponential functions. Okay, so determine whether each of the following is best represented by a linear or exponential function. Okay, remember that linear is where it's got a common difference. And we initial that with a D, or we have an exponential functions which have the common ratio, right? So linear is adding, subtracting, exponential, multiplying, dividing. So part one, question A, Gideon saves $5 every week. Okay, so is it multiplying by 5 every week, or is it adding? In this case, it's adding, so this would be, I just put D, but it is linear. Oh, my stylus is not working correctly. Try that again. There we go. Mr. Miller uses a herbicide to kill the weeds in his yard. Each month, there are half as many weeds as there were in the previous month. Okay, so this is cutting the number in half, right, which we know to be is 1 over 2. So this would be exponential. It's multiplying or dividing. Okay, a population of mosquitoes triples every week. So is it adding 3? No, it's multiplying by 3, so this would be exponential. Okay, in every month, 20 new people move into Hilliard, meaning 20, we're adding that 20 people into Hilliard, so this would be linear. Okay, all right, so let's look at some applications here where we're going to graph them, talk about domain, and then identify what type of function it is. So the first one says Chase has $100 in his bank account. He saves $20 per week. Fill out the table below and graph the function. Okay, so before he even starts saving, right, 0 number of weeks, he has $100 in his account. And then he saves $20 per week, meaning we add 20 each time. So that puts us at 120, 140, 160, 180. And of course, we're just going up by 1 week at a time. Okay, so what is the domain for this function? Meaning, what are the x values, right? Well, we know that this function right now only has 4 weeks involved, okay? And it starts at 0 and goes to 4. So one way that you could say this would be, if we're just talking about this, we would say from weeks 0 to 4, right? Including those weeks. However, because it says, you know, he's saving 20 per week and it doesn't tell us when we're actually stopping, we're just filling out a table, then we would say this probably extends past 4 weeks. I'm going to assume that Chase is not just saving for 4 weeks. So we're going to say that this goes to infinity, right? Or that you could say that your domain is any number bigger than or equal to 0. So any x value bigger than or equal to 0. What does this represent? Is it a linear function, exponential function? In this case, it is linear because we're adding. And would this be arithmetic or geometric? So arithmetic is adding, right? So that would be arithmetic. Okay, so let's go ahead and plot these points. As you can see, I filled out the axes already. So 0, 100. Let's go ahead and make that bigger dot. We'll just put it in blue. It's going to be right here. Okay, 1 and 120 is right here. Oops. Right there. 2 and 140. There. 3 and 160. There. And 4 and 180. Which is there. Okay, there we go. And we're not going to draw a line because even though he is saving weekly, he's probably only dropping that $20 into his account every week and not during the individual days. Okay, application 2. The first year Josh had 20 fish in his pond. The fish double in population every year. Okay, so this says after the first year. And I'm going to actually shrink this back down. There were 20 fish. It doubles. So that would mean 40. And then 40 times 2 is 80. 80 times 2 is 160. And 160 times 2 is 320. So 2, 3, 4, 5. So this actually doesn't start at 0 because it says the first year, right? So after the first year, he's got 20. I'm going to actually go ahead and plot this one in advance. So 1, 20, 2, 40, 3, 80, 4, 160, and did we have a 5? We did. And 5, 320, which is all the way up here. Okay, so as you can see, that's going to be more of a curved graph, which means this is exponential. It is geometric. And what is the domain? Again, we could say that it could go on forever, but in this case, we're going to say that it starts at x is greater than or equal to 1. And, you know, if we're just talking about this table, we would say from 1 to 5. But it doesn't look like it's actually stopping at 5 years. So this is probably going to be more of our answer. Okay, application number 3. Francis and Aubrey both earned new jobs after college. Francis's position earned a signing bonus of $2,000 plus an hourly rate of $21. Aubrey's new position earns a signing bonus of $1,000, but a higher hourly rate of $25 per hour. Okay, write a function f to represent Francis's earnings in terms of x, the number of hours worked. Okay, so Francis, signing bonus of $2,000, and then an hourly rate of $21. Okay, so a signing bonus, for those of you that don't know, is a one-time payment that you get just for signing your contract, right? And as teachers, of course, we do not get this, but it would be nice. So Francis's function, f of x, right, is going to be $2,000 plus 21 times x, because he's getting paid an hourly rate of $21. So that's what's going to actually change his rate, right? Write a function a of x to represent Aubrey's earnings. A of x, okay, would be 1,000 with an hourly rate of 25. So we're going to say a of x equals 1,000 plus 25x. Okay, if they both work 40 hours their first week, how much would their combined gross be? So in this case, they're saying let's add f of x plus a of x, and let's plug in 40, right, for both for their hours worked. So we're going to have 2,000 plus 21x, but we're going to change that to be times 40, plus 1,000 plus 25x, which again, we're saying that they're working 40 hours. Okay, so 21 times 4 is 82, so 800, or 84, I'm sorry, 840 plus 2,000 plus 1,000 plus 25 times 4 is 100, add the 0, right? So we're going to have another $1,000. So after 40 hours in the first week, they would earn a total of 1, 2, 4, 840. So this would be $4,840 their first week combined. That's pretty good. How many hours would they both need to work to reach $10,000 if they combine their income? Okay, so in this case, we don't know how many hours they're working, right? And it could be more than 1 week, of course, but $10,000 equals, in this case, their combined income, right? So we have 2,000 plus 21x plus 1,000 plus 25x. Okay, and if we combine those, we have 10,000 equals 3,000, right? Combining those, combining these, plus 46x. Okay, subtract 3,000. Oops. Trying to go somewhat quick here. I know this is turning into a longer video, so I apologize. Equals 46x. And then divide both sides by 46. And we have that x is about, let's see, do we have a calculator on this? We do. Oh no, it needs to install. Well, that's not good. Let's see if it installs somewhat quickly. There we go. Okay, I don't care about your premium features. All right. So 7,000 divided by 46, 152 hours. 152 hours. So about 100. We'll say that they actually have to work about 153 combined hours, right? So definitely more than 1 week, unless they're both working 76 and a half hours in that first week. probably not likely unless they're lawyers. And then it's probably accurate. Okay, let's go ahead and end it there. And tomorrow in class, we're going to look at this one in groups, and this one in groups, and this one in groups. Okay, so if you want, go ahead and try all three on your own tonight or tomorrow, and then in class we'll talk about them together. All right, we'll see you then.